Alright guys, so in this question we say to draw a radial cam to operate a knife edge follower on inline position using the following data. The cam data: rise 0 to 150 degrees with simple harmonic motion, dwell 150 degrees to 180 degrees, that's the rest interval, fall 180 degrees to 360 degrees with uniform accelerated motion. The lift is 48 millimeters, the base circle radius is 30 millimeters, the follower is a knife edge follower, follower position inline, while cam's rotation is counter-clockwise. Alright, so let's start by drawing the displacement diagram of the cam. So you just draw, you pick any convenient space and you draw an horizontal line. Then your lift, as mentioned from the question, that is the maximum height of the rise, is 48 millimeters. So this is 48 millimeters, 4.8 centimeters. So I've measured my 4.8 centimeters. So what do we now do next? From the question, we were already told that from the rise is 0 to 150 degrees. So how do we divide that into 6? How do we get into 6 equal parts? That is 150 divided by 6. That will give us 25 degrees. So now we're using we're trying to get a convenient scale that will make our work neat. So since we're using 25 degrees each, dividing into 6, the scale, let's use 1 centimeter to 25 degrees. So let's start our 1 centimeter position. So this is 1 centimeter, this one, this is another, this is another 1 centimeter, another 1 centimeter. All right, so let's do the numbering. This is 25 degrees, this is 0 degrees, this is 50 degrees, 75 degrees, 100 degrees, 125 degrees, 150 degrees, and our rise position is now completed. So now what do we now do next? We make vertical lines upward from this point. Alright, so now that we have extended our points upward, so let's get an horizontal line upward that is exactly at this 48. Alright, so it's now at the 48, so you clean the extras. Alright, so we've gotten the rise portion. So the question said it tries with simple harmonic motion, so we don't have to stop there now. We have to draw a semicircle at this position here, since it's a simple harmonic motion. So the radius of this semicircle is half of this total length here. So the total length from here to here, remember, from here to here is 48 millimeters. So the radius will be 24, since 48 divided by 2 is 24. So you find the midpoint. carefully. Alright, so I just got my midpoint. You hold your compass firmly to avoid slips. Alright, so that is done. So we'll move to the next part, dividing this semicircle into 6 equal parts. So how do we achieve that? We use a protractor, placing the protractor at the center of this circle. So we are dividing into 6, and this is 180. So 180 divided by 6 will give us how many degrees? So 180 divided by 6, that's 30 degrees. So we take 30 degrees each, 30 degrees each. So this is 30, this is 60, 90, 120, 150. Alright, so now from the midpoint, from the center of the circle, we extend these lines outside. Extend them outside. Alright, so since we have gotten that, now we move to what is next. So what is next is projecting these points, which we will number 1, 2, 3, 4, 5, and 6. We project it horizontally. Alright, so this is not supposed to go more than that one. Alright, so we've successfully projected it horizontally. So what then do we do next? So we take the points where the vertical and horizontal line intersect, starting from this 0 point. So this 0, alright, so the next thing, we use either a freehand or we use a French curve to join those points. make sure it's properly aligned. Alright, so that is that for the rise position. So we can mention it if we want. So this is the rise position. So now we move to the dwell position. Remember, our scale is 1 centimeter to 25 degrees. So now how do we get our dwell position? From the question says it dwells from 150 degrees to 180 degrees. That means it's rested for 150 degrees to 180 degrees. So let's find the difference between the points 150 and 180 degrees. So it's 180 minus 150, which is 30 degrees. But from our scale, we have 1 centimeter to be equal to 25 degrees. So x centimeter now will be equal to 30 degrees. So we want to get the distance we'll use for this 30 degrees. So x will be equal to 30 times 1, x times 25 rather, 30 times 1, while x will be equal to 30 over 25. And if you punch this on your calculator, 30 over 25, what you get is 1.2. Alright, so what we'll be using here now is 1.2 centimeters or 12 millimeters for our dwell length. Alright, so as usual, you project it upwards. You continue 1.2, 1.2, 1.2. Next one will be 2.4. This one will be 3.6. 4.8. Next one is 6, and then 7.2. Alright, so let's project these lines upwards. Alright, so let's number 180 degrees. So we can just be increasing by 30 till we get to our last one. So this is 180 to 10 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and this is 360 degrees points. So these extras are not useful, so you just cancel it out. So yeah, so let me do a recap before we proceed. So I said for for the rise position from the question, you see it rise with simple harmonic motion. So to get that curve, we draw a semicircle at the left hand part, the left hand side of the displacement diagram. So this is the left hand side of the displacement diagram. So we draw a semicircle and divide it into 6 equal parts and project it using horizontal lines. So on the displacement diagram now, it is being projected. We mark the points where it intersects with where the vertical line and the horizontal lines intersect, and then we connect using our French curve. So we move to the next one, which is the dwell. So the dwell, we calculated the dwell, the length using our scale, and then we move to the fall. The distance from the fall, the difference of the fall, where the fall started, the dwell, and where the fall ended is 180 degrees, because 360 minus 180 will give us 180 degrees. So divide it into 6 equal parts as we have done for the rise, and it is 30 degrees each. So we keep adding 30 degrees till we get to 360 degrees. All right, so we move to what is next. How then do we get our curve for the uniform accelerated motion? Remember, the question says the fall is with uniform accelerated motion. So how then do we get our fall? So this is a very a bit tricky process, but it's actually easy. So from where your fall starts, that is 180 degrees, get your midpoint. So midpoint 1, 2, 3, 1, 2, 3, and the midpoint is what? 270 degrees. So these are midpoint. So you divide that midpoint into what? 6 equal half. The total length is 48. So dividing 48 into 6, 48 divided by 6 is 0. Sorry, this 8. 48, that's 8 millimeters. That is 0.8 centimeters. So you mark it on your ruler. 0.8. The next one will be 1.6. Next one will be 2.4. Next one will be 0.2. We have 4, and then 4.8. So that has been perfectly divided into 8. So now what we do next is just to project it horizontally. Right, so it has been projected horizontally. So we move to what is next, getting the camp profile itself. So remember, these are the points we divided. So we just label those points A, B, C, D, and E. A, B, C, D, and E. These are lines we projected are just thin lines. You're not supposed to show much. If possible, just very, very thin. So the pencil shade. All right, so let's project these down backwards. All right, so from the end to end we just have to start connecting now. So from this point E to this end point, the topmost of the 180 line, you connect Z to the topmost, you connect that topmost through C to 380 degrees, to 360 degrees rather, and also 330 degrees to connect 360 degrees to A. Also connect 360 degrees to B. Alright, so we have gotten our sketch that's going to direct us on how to get the point. So you take the point where these lines intersect with the vertical lines. Alright, so these are points, and then you join using your French ball. Remember, these lines you projected are supposed to be very thin. Alright, so bringing it to get perfect curve that's gonna. Alright, so oh, this will work. Yeah, this works. Alright, so it's already connected through this to that point. You can just use your hand to make it thicker. And then come back to projecting our vertical lines properly. On the end horizontal lines. Alright, so for the dwell, we usually do not use the curve there, just a straight line as it is now, just a thick straight line. Alright, so I've finally gotten our displacement diagram. We've gotten our displacement diagram. Alright, so let's be A, B, C, D, E, F, G, H, I, this is J, K, L. So let's make it a little bit thicker. Alright. Alright, so since now we have gotten the displacement diagram, we can proceed further. If we decide to this is dwell, while this is the fall. Alright. So we can now proceed to drawing the cam profile proper. This doesn't want to erase out. Also, we just leave it there. So before we can draw the cam profile properly, we need the vertical displacements for this or our numbered alphabets. So let's make a table for that. We have 1 2 3 4 5 6 7 8 9 10 11 12. So we have 12 points to represent this 5 6 7 8 9 10 11 12 points to represent inside the displacement table. So but we are not drawing to scale, we're just making a table. We make it small but clear enough so you can read your values out back. So the angle, point, the point, and vertical displacement. In millimeters. Alright, so we are not drawing this table to scale, we're just drawing any random table to fit in our values so we can easily compute it. Alright, so this A, B, C, D, E, F, G, H, I, G, K, L. Alright, so but if you are doing it, you can decide to draw to scale, maybe using 1 centimeter, but I think it's going to be very big for if you use that scale. But just use a convenient scale that doesn't make it too big or too small. Alright, so this is what we are doing right now. So what does this displacement table, what are we computing there? We're computing the vertical length from this horizontal baseline to these are points which we have lettered up there. So using your ruler, you measure the distance from here to here. We have our first one to be 0.3 centimeter, which is 3 millimeters. I said in millimeters. So this second one is 1.2 millimeters. That is 1.2 centimeter. That is 12 millimeters. This is 24. This is 38. Sorry, 38. Yeah. This is 46. And F48. G also 48. H 46. I 30. 38, J 25, K 23, L 5. Alright, so we're getting our displacement table and filling our values. So we'll move next to drawing the cam profile proper. Alright, so from the question says our base radius is 30 millimeters. So we pick our compass and then we measure the radius of 30 millimeters. Remember, we are doing for a knife-edged follower, so this 30 millimeters. So now we draw, take a convenient spot. Guys, so this is a base circle. This is our base circle. On the base circle middle, project vertical line from top to bottom. Alright, so from top to bottom. Let's move next. So we are transferring these points to this base circle. So for our rise, remember the question says it's moving counterclockwise, but while drawing the cam profile on the base circle, you will number clockwisely. If the question says it is moving clockwise,ly you number counterclockwise,ly. If you say it is moving clockwise,ly you number counterclockwise. If it's moving counterclockwise, you number clockwise,ly, like you do the opposite. So that means counterclockwise is this direction. Sorry, counterclockwise is this direction. So we have to start do our numbering this other direction. So that means our 25 will be here. To accurately transfer these points to this circle, now you use your protractor. So this is 25, 50, 75, 100, 125, 150, and that's 150 points. So we start extending to the middle, to the center of the circle. The lines do not have dimensions, just have to make them radial. Alright, so it is 0 degrees, 25, 50 degrees, 75 degrees, 100 degrees, 125 degrees, and 150 degrees. Alright, so let us move on to, this is for the rise. Let's move to the fall. So this is 180 degrees. Remember, half a circle, the angle is 180 degrees. So yes, 180 degrees. So from this point to this point, this point to this point here, This is 150. This is our dual. So we move to our fall. The fall is also 6, and this is 180. So dividing by 6, we use 30 each. So let's get started. 30, 60, 90, 120, and 150 now. Alright, so let's project this point. Sorry, the weather is getting dark. This way, this way, this way, and this way. Alright, so we've been able to draw the radial lines from our base circle. So what are we doing next? We transfer these points to this from the circumference of the circle. We transfer these exact points using a meter rule. So 3 A is 3, B 12, C 24, D 36, sorry, 38, D 46, F. From these are values from our displacement table. So F48, record the map. Alright, so we say this A, B, C, D, E, F. Alright, so we can proceed by joining those points. You can either use freehand or use your French curve as usual. So we join those points carefully. So this curve is seeming to be going to waste our time, so we'll just use freehand. But I'd like you find a better angle to position the curve to make proper use of it. If I try to adjust it, I'm going to shake the camera and disrupt the video, so I'm just going to use freehand to connect these. Alright, so that's quick. Alright, so now we move to the dual position. which is this G we measure to F. So G is 48 from our displacement diagram. 48, 46, 38, 25, 23, 5. Oh, we made a mistake here. This K, let's come back and recheck our measurements. So it's actually 11, not 23, so this point flawed. I would like for it, when you're drawing, try to reconfirm. So this point is actually 11 at this point. So it is G, H, I, J, K, and this is point L. So now we can start joining these points. The dwell point should be very smooth. The curve at that position should be very smooth. So now we can use freehand for the rest. Okay, so that's perfect. Alright, so joining to this 0 position. Alright, so we're almost done. Almost done. Alright, so we just successfully construct the cam profile, but we are not done yet. You state the direction from the question. It says moving counterclockwisely